I'm going to talk a little bit about one of the tools we're using to think about grizzly bear reintroduction and maybe more broadly why reintroduction is a tool that we even think about. And part of that is building resilience through biodiversity. I mean, in the simplest terms, the more original players of the ecosystem you have, the better chance you have of dealing with change through time. And as I talk about this grizzly bear tool, I want to recognize there at the bottom of the screen my collaborators who are not Park Service, all from different organizations actually, but Andrea Lyons, who carried a lot of the modeling heavyweight on this, Catherine Hegewisch, and Mead Crosby, who we're going to hear about later. Next slide, please. We do look at an ecosystem perspective from the Park Service lens. Where the National Park Service complex is that sort of wedge in the middle of the map there that's darker shade. It is a transboundary ecosystem that's quite big. I mean, 20,000 square kilometers is actually one of the largest intact wilderness areas in the contiguous US. It's a big palette to work with when we think about how do we manage this. And we're fortunate that we have almost a completely intact historical assemblage of animal species. And by historical, we're probably talking millennia, except for a few players. Fishers were extirpated by humans sometime in the last century, turn of the century, took a lot of pressure, but they were wiped out for the fur trade. Over the last 2 winters, we have released 89 fishers back into the North Cascades. And as we speak, they're out there being fishers and hopefully making their way back into our ecosystem. Cascade red fox are not in the core part of this ecosystem, but they're still around in the state. And in fact, you can see them down at Mount Rainier. So they're around and we're trying to figure out why they are and aren't where they are. And then grizzly bear is the last big one. And it's a big one because it's considered a keystone species. And by keystone, we mean a species that really has sort of an outsized effect on the ecosystem around it. And grizzly bears are just gone. So next slide, please. So the first task we did was to take a deep dive into sort of what do we know. And you'll see on the left, there's a cover of a report we released a couple years ago. If you can see on the bottom of the screen, irma.nps.gov is the sort of data and publication clearinghouse where all this stuff is open access. So there's a big document where we did a deep dive, talked to tribes and First Nations. We dug through all sorts of historical records and fur trade records and everything else to say, were they here? Where were they? How many were there? And as you could guess, it's a piecemeal sort of thing because the trail is thin and we don't have data on existing grizzly bears in this ecosystem. But the spoiler is, yes, they were here and now they're not. The last confirmed record was a single bear in Manning Provincial Park in British Columbia in 2015. There've only been 4 confirmed sightings of grizzly bears in this ecosystem in the last decade, and we're pretty sure most of those are the same individual bear. They're functionally extirpated. There's no breeding. There may be a few animals out there somewhere. The second part of this equation on the right was a deep dive into sort of what resources are here that grizzly bears would use based on what grizzly bears use everywhere else, which is our best tool, right? To look at similar ecosystems and say, what do grizzly bears eat? Where do they live? What do they need for denning? What do they need seasonally? And we looked at sort of the climate change, the broader sort of qualitative ideas on climate change effects that this ecosystem might see. And when we crosswalked all of the data about science and diet, we came up with 2,500 plant and 450 animal species that we know are grizzly bear foods or related to them. And so, yeah, we think there's ample resources here. Next slide, please. And so we did this tool where we crosswalked a few different modeling platforms. And so on the left, we said, what do grizzly bears need? And we looked at a resource selection model developed on the transboundary with Canada, where they do have bears. And basically there's these 5 things: this sort of index of greenness, the openness of the canopy, the alpine vegetation, the riparian or near water vegetation, and elevation, and then this important factor of how close are all these things that grizzly bears need to roads, because roads have a negative effect on bears across their range. The second step in the middle was, what will this ecosystem provide in the future in terms of those things that grizzly bears like? And we looked at really 36 combinations of things, but it's 20 global circulation models, a low and high greenhouse gas scenario. And we put them all in this MC2, this dynamic vegetation model, to say if you can throw all this stuff that we know bears need into the future, what does it look like in the future? And the last part is the easiest wildlife reintroduction, is just to create imaginary bears in the computer. So we created these cyber bears and we dropped them into these vegetation models with all these future scenarios. And we used two different flavors of bears. We used established females that have a home range. We used 3 different sizes based on the known literature on what sizes bears pick in other ecosystems. And then dispersing females, which don't have a home range. They're dispersing, they're trying to find their place in the world. And so we put all these imaginary bears in the ecosystem. We let 50 years elapse for them to sort of settle out, kill off all the extra bears, let the ones that live there set up shop. And then 100 years of just simulated living in the ecosystem through these different models of change. Next slide. And what we found was really surprising. This is a busy map, but if you look at the broader spectrum here, the yellow and gray is sort of poor quality habitat, and the green and blue is better quality habitat. And what we found is that sort of worst case scenario, 77% decrease in the bad habitat, but 197% increase in the good habitat. And so if you look at the bottom row of that, that's the 20 model average. And on the very far left would be the lowest emission scenario in the near term, the 2050s. And all the way on the bottom right would be the highest emission rate through 2099. And what you can see is that darker shade of good habitat really is pervasive. And so the high quality habitat increased across all the scenarios and all the models through all the time periods, which is really positive for grizzly bears. Next slide. And in terms of what that means for how many bears could live there, in the current world right now, if there were magically bears out there, we estimated that this ecosystem would support about 139 females. And so if you assume a 50-50 ratio, then that's about 280 total bears. If you go to the future, of course, there's a whole spectrum of models and scenarios, but roughly the carrying capacity would jump up to 241 to 289 females. And so in the map terms there, which is on density, we'd go from a current situation of about 17 bears per 1,000 square kilometers to 20 to 22 bears per 1,000 square kilometers. So again, on that bottom row is the 20 model average. On the bottom left would be the lowest emission scenario in the nearest term, the 2050s. And the density there is sort of in the core of the habitat, 9 to 10 bears, female bears per 1,000 square kilometers. And then on the far right bottom, again, you have the sort of worst case scenario. And you see the density goes up in the middle of the ecosystem. And I'll point out across these scenarios, we see the density is low and goes down a bit around the edges, and especially in the east side edge of the ecosystem. And so there's sort of an added bonus at a finer scale here, which is that the better habitat moves up in slope, up in elevation, which fundamentally pulls bears farther away from people because we tend to live and farm and have roads in lower elevation. So there's a couple silver linings there. Next slide. This is the last slide, actually. And so through this exercise, we can say that, yeah, grizzly bears are actually climate change winners in this ecosystem. And so that's great, but they don't exist here right now. And so they have to exist for them to be winners. If we could put them back, we might realize this fairly major piece of biodiversity that this ecosystem has been lacking due to humans extirpating them. Unfortunately, they're not likely to return on their own. If you look at southern British Columbia, grizzly bears are wiped out. There's no contiguous relationship with the Rockies or northern British Columbia bear populations. So if we wanted to put them here, we'd have to physically put them here. And I'll point out lastly that ecology is not the same as coexistence. We can do all this work and we can say this is great habitat and we can put bears here, but that's not the same as living with them. And when we talk about putting large carnivores back on the landscape, it requires, you know, a broad array of stakeholders to say, can we do this? Should we do this? And then how do we do it right so that we all benefit from it? And there's lots of question marks there that I'm going to have to leave you with because we have limited time. But that's where we are working towards thinking about this big action. And